Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about centroids of areas. First of all, we'll talk a little bit about definition, but I don't want you to get too hung up on the definition part. I will then talk about how this definition works when we're working with areas where we can find the centroid without calculus, but then we'll focus on how we use calculus to find the centroids of many areas. So to start with, I need to talk about the concept of moment of force, and it's also called first moment, and it's described, moment of force about some point is the product of the force and the perpendicular distance from the point to the line of action of the force. Similarly, moment of an area will be equal to the product of the area times that perpendicular distance from the axes to the centroid. Therefore, the distance from the axes, and this will either be the distance from the x-axis or the y-axis, depending on which coordinate we're finding, will be equal to the moment of an area divided by the area. Let's take a look with some geometric shapes where we can find the centroid without calculus. If we were to take a look at this rectangle, and I was asked to find where is the centroid. Centroid's also known as center of mass. Because there's symmetry with this rectangle, it would be right in the middle. So the intersection of the two middle lines would be where that center of mass or centroid would be located. So in this example, the x value is, for the whole rectangle, is 5. So the x value of the centroid would be right in the middle of that, would be 2.5. We use this symbol to represent centroid, the x-coordinate of the centroid. Similarly, the width of the rectangle is 4 units, so halfway between 0 and 4 is 2, so the y-coordinate of the centroid would be 2. And anytime you have shapes that have those axes of symmetry, it's going to be easy to find the centroid. If we were to add another rectangle, so let's say I had a shape, a thin shape that was this whole area, and I now wanted to find the centroid of that whole shape. What I would do is I would find the centroid of this particular rectangle as well. For this rectangle, the x-coordinate will be, if I go from 0 to -2, right in between, right in the middle of that, is x equals -1. And the y-coordinate will be 1, 2, 3, 4, 5, 6. So the y-coordinate will be when y is 3. So in order to find the centroid of this total shape, I'm going to call that the x-coordinate of the centroid of the first shape, and this is the y-coordinate of the centroid of the first shape. Similarly, those are the coordinates for the centroid of the second shape. So this is shape 1, this is shape 2. I'm going to find the area of shape 1. It will be 5 times 4. So area 1 will be 20. And the area of this rectangle will be 2 units by 6 units will be 12 square units. Then I'm going to find the x-coordinate of the centroid for the whole shape by taking the total moment about the y-axis and divide by the total area. So the total moment will be the sum of the individual moments. So I take the x-coordinate of this centroid times this area plus the x-coordinate of the centroid of this shape times this area. Then I divide by the total area. So I will get 2.5 times 20 plus -1 times 12 divided by the total area, which is 20 plus 12. So I'll get 50 minus 12, which would be 38 over 32. Would be 19 over 16. That will be the x-coordinate of the centroid for this whole shape. I'll do the same thing to find the y coordinate of the centroid, but I'm going to find the moment about the x-axis. This coordinate times the area plus this coordinate times its area and divide by the total area. So when I do the calculation, I get 76 over 32, and I can reduce that to 19 over 8. If I want to write those as decimal values, it might be easier to place the centroid. I can do that. And then the centroid of this whole shape will be 1.1875 and 2.375. So that's the centroid for this whole shape. Those are the coordinates: 1.1875, 2.375. Now, usually you're not going to be given shapes that are both axes where they have two axes of symmetry like that. Typically, we're going to be given any shape, and you're going to be asked to find the centroid. In order to do that, we're going to need calculus. So I just wanted to show this with something where we didn't need calculus, and hopefully that helps you understand the idea of summing up all of the first moments and dividing by the total of all the areas. Let's take a look now at how we find centroids using integration. In order to find the centroid of an area, so I'm talking about the area defined by or bounded by the top curve f of x, the bottom curve g of x, from x equals a to x equals b. And in order to find the centroid, what I have to do is first of all find first moment. And I can find the first moment of my representative rectangle by taking the distance, the perpendicular distance from the y-axis, and multiplying by the area of that. And then I can sum all the first moments of all of those strips by integration. And then when I've got the sum of all of those first moments by integration, I divide by the total area. The x-coordinate of the centroid would therefore be defined as the integral from a to b of this perpendicular distance, which is x, times the area of this rectangle, which will be described as f of x minus g of x, times the width of it, which is dx. So this will be the sum of all the first moments of that area. I divide that by the total area. Now, in order to calculate the total area, I am going to do another integral, but I don't want to write it as an integral because then people might be tempted to start canceling things. What I am going to do instead is write this as 1 over a, where a represents the total area of this shape, times the integral like that. That's how we find the x-coordinate of this centroid. In order to find the y-coordinate of the centroid, I do the same idea, but it's a little trickier expressing the perpendicular distance to the x-axis. To the y-axis, I just wrote it as x, but the distance to the x-axis is y, but I don't want to have y in my formula. I want to have it all in terms of x. So the distance to the x-axis will actually be the average of f of x and g of x. It's the point right in the middle of those. So I can write that average as f of x plus g of x divided by 2. That's going to be the average y value of that rectangle. That's the point right in the middle. Then I take that perpendicular distance and multiply by the area of this rectangle, and the area we know is f of x minus g of x times the width is dx. So that the f of x minus g of x is the length of it, dx is the width. And I take this and divide by the total area. So this is the sum of all of the first moments with respect to the x-axis. And now I want to simplify this because I don't want to have to do this every time I need to calculate the centroid. Because I can take this 1/2 and pull it out front of my integral sign, I'm going to do that. And then I'm going to simplify this. In simplifying that, I'm going to combine the 1/2 that's outside of the integral sign. I'm going to divide that by the area. So I'll get the y-coordinate equals 1 over 2 times the area, then times the integral from a to b of, when I multiply f of x plus g of x times f of x minus g of x, it's just like multiplying with here. The result will be f of x squared minus g of x squared dx. So this is the formula I use to find the y-coordinate of my centroid of my area. So that's how I find the x-coordinate. That's how I find the y-coordinate if I'm using vertical rectangles. Let's do an example so I can show you how this works. Question asks us to find the centroid of the area bounded by y equals 4x squared, the x-axis, and the line x equals 1. So first of all, we're going to draw it. So the area bounded by those three functions is this right here. So we want to find the centroid of that area. I'm going to find my x-coordinate first, but before I actually find that, I'm going to find area first. So let's find the area of this. We already know how to do that through integration. It's going to be the integral from, in this case, a is 0, b is 1. So from 0 to 1. The top curve, which is 4x squared, minus the bottom curve, which is just y equals 0, dx. So that will be 4/3 x cubed, which will be 4/3 square units. So that's my area. I'm going to use that in my formula for finding the x-coordinate as well as the y-coordinate. So the x-coordinate will be equal to 1 over the area of 4/3 times the integral from 0 to 1 of x times f of x, that'll be the top curve, which is 4x squared, minus the bottom curve, which is 0, dx. 1 over 4/3 is 3/4 times the integral. Let's simplify this before we integrate it, so it'll be 4x cubed dx, and that will equal 3/4 times x to the 4th. Put a 1 in, and I get an x-coordinate of the centroid as 3/4. Now we'll find the y-coordinate. So in order to find the y-coordinate, I use this formula. So the y-coordinate will be 1 over 2 times a times the integral from 0 to 1 of f of x squared, so 4x squared, minus, it's always nice when the g of x is 0, so minus 0 squared dx. So let's simplify first. So that's 1 over 8/3, which will be 3/8. And then the integral of 16x to the 4th dx. That will be equal to 3/8 times 16/5 x to the 5th. When I put a 1 in there, I get 3/8 times 16/5. The 8 will cancel to give me a value of 6/5. So I now have my two coordinates of my centroid. Will be located at the point 3/4, 6/5. In the next video, I want to do another example using vertical rectangles, and then we'll take a look at how we find the centroid if we have to use horizontal rectangles. See you.